We're on site at a leisure centre today where we've supplied a 200 kilowatt CO2 heat pump. Due to its thermodynamic properties, CO2 is extremely efficient at heating hot water to 60, 70, 80 degrees. Its efficiency actually depends on the return temperature back to it. So anything below 40 degrees, but preferably below 30 degrees, will give a super good efficiency, somewhere between 3.5 and 4 as an SCOP. The unit behind me isn't the complete heat pump. This compressor unit is attached to 2 evaporators which sit outside the building. There are 4 pipes which connect the inside unit to the external evaporators. 2 of the pipes are for the refrigerant and the other 2 are for the warm glycol for when the system needs to defrost. These evaporator units blow air across a coil where they absorb heat energy from the air into the CO2. That CO2 then starts to change state. That's fed up into the plant room where the compressor unit pressurizes that CO2, then comes off extremely high pressure, high temperature, where we exchange the heat to the water. So this is where it all happens. We've got 3 door-in H compressors here. We've got the inverters which run the compressors. This is the refrigerant to water heat exchanger, so the copper pipes are the flow and return for water. The flow and return from the heat exchanger we've just seen connects onto this buffer vessel. We've got a couple of plate heat exchangers here which transfer heat from the buffer vessel to the cold water feed into the building. So sometimes both of these plates are operational, at other times just one of these plates will be operational. This means that we're producing instantaneous hot water from that system to the building. The question everyone asks is, how do we keep the return temperature low? Something very special about this buffer vessel, and that is that we control the stratification in the tank. So as I mentioned before, we need a coldish sort of feed back to the heat pump to keep it efficient. The second heat exchanger, as I mentioned before, is actually sometimes used to, it's got 2 uses: to preheat the hot water which is coming onto this plate, but also at certain times to cool the bottom of the tank. We're not damaging the efficiency of the system while we're doing that. We are transferring heat from that buffer, preheating that water, but simultaneously cooling the bottom of that buffer vessel so that we ensure that cold return back to the heat pump. When it's cold outside and there's moisture in the air, we will accumulate frost on the coil of the evaporators, and so we need a defrost system. The other little plate heat exchanger which you see right there, that's actually for our hot glycol defrost system. So what does that mean? Okay, this plate heat exchanger steals some heat from this buffer vessel, transfer that from water across the plate heat exchanger to glycol, and that glycol is then pumped out to the evaporator units when they are frosted up. So we run hot glycol through an interlaced coil on those evaporators. This hot glycol defrost system, we do 2 things. We have continuous heating operation, but we also make the heat pump very slightly more efficient. As we said before, the heat pump relies on a cold return to be efficient. So by stealing this little bit of heat across this plate heat exchanger, we make the return a little bit colder, and it makes the heat pump system even more efficient. In case of a refrigerant leak, there's a leak detection system. If that leak detection system goes off, this ductwork is connected to an extract fan. It would detect the refrigerant and then it would start that extract system. You've got those 3 pipes which actually come off the top of the unit and then go out the side of the building. They are emergency high pressure discharge pipes. So there it is. Hopefully now you know a little bit more about CO2 heat pump systems. They really are best way to heat high temperature hot water. We get really good efficiencies, we can have running costs lower than gas, and so it's a solution which not only decarbonises, it actually works from an economical point of view as well. If you want to talk to us about CO2 heat pumps, we're really interested in having a chat with you. You can contact us here on LinkedIn, or you can message us on email info@icgheatpumps.co.uk.